So we look at the second question. Okay, so the second question reads, evaluate the following integral, the integral of sine root x dx. So I've already done the first question. Okay, you can watch one of my videos that I've recorded. Okay, so we are integrating sine x. No. Okay, so what's the integral of sine x? Means sine root x. So what method are we going to use? Okay, so first of all, I'm going to apply U substitution. Why am I going to do so? I'm trying to convert, okay, from x variable to a new variable. The reason being here is that if I was to integrate the way it is here, look at the input of sine, it's a square root of x, okay? It's not a linear function where you can just differentiate it and it becomes a constant, okay? Just a reminder, if you have cosine, if you have a sine of, let's say, function, f of x, the integral of this should what? Negative cos of the same function, f of x, divided by a constant, okay? A constant is a number, okay, that you get after differentiating the input to a sine function, isn't it? But if you look at what you have here, the input is root x, right? So you can tell me that, okay, the integral of this will be negative cos root x, right? Divided by, what's the derivative of root x? The derivative of root x is not a constant, isn't it? Yes, because the derivative of root x is simply what? 1 over 2 root x, isn't it? So you see that this is not a constant, okay? So this is not going to hold if you are just integrate direct, isn't it? But if it was like a sine of 3x, sine of what, you know that if I differentiate that, what I have inside here, the derivative of 3x, I'm going to get a constant, okay, in the denominator, right? So this can't work in this case, right? Okay, it can only work if the input to a sine function or a cosine function or a tangent function is what? Is a constant. But what you have with root x, if we differentiate that root x, we're not going to end up with a constant. Okay, so we need to find other ways. So we have to replace that root x with a function that is going to, when we differentiate it, we end up having what? A constant value, right? So that's the reason I want to, okay, let's try U substitution. Let's change, okay, instead of us having root x here, what if we have U inside that, right? As a sine U. So how do we do that conversion, right? Okay, so I'm going to say let U is equal to root x, right? Okay, so meaning that in place of root x in this sine function, I'm going to replace it with a U, right? Now, if I differentiate this U, remember that every time if you say let U equal to something, you also need to take the derivative of that, right? Yes. And if I take the derivative of that, I'm still going to have an x because I know the derivative of this guy, U prime, I have what? 1 over 2 root x, isn't it? I'm still having this x. I haven't gotten rid of it. And this root x, I don't have any root x in this function that is going to cancel out this root x. So I need to do something, right? Let me do something. So what I'm going to do here, instead of me just letting this is equal to root x, I'm going to square both sides, right? Okay. So if I square both sides, I have u squared equal to x, right? Okay. Now this one, I can take the derivative because if I do that, I'll get rid of x. Remember that I don't want to see x anywhere. I just need to have a new variable. Okay. So what is the derivative of u squared? This is it. 2u du dx, right? Remember that I'm differentiating this with respect to x. So this is it. 2u du dx, right? And then what is the derivative of x with respect to x? This is just equal to 1, right? Okay, I don't want to see anything that has to do with x here. So it means even dx has to go, isn't it? So I'm going to make dx the subject here, right? So if I make dx the subject, I'm going to have what? 2u du, right? Yes, you're right. Okay, so let's make that substitution here. So meaning that the new integral is going to look at this. I have sine, in place of root x, I said that is u, right? Okay. In place of dx, I said, oh, this is 2u du. Okay, at least now you can see something familiar. Very easy to do, right? You can integrate sine u. Okay, so I have two functions, a product of two functions. What technique are we going to use, guys, here? Yes, you're right. Integration by parts, right? So we're going to apply integration by parts. Okay, so how do we apply integration by parts? Just need to remember that if you have sine, if you have u, this is a general formula, right? U dv, this is equal to uv or vu minus the integral of v du, right? Okay, so from the given two functions, you have to pick which one is a u and which one is a dv, isn't it? So we have u and dv. So which one is my u here? Oh, some people have troubles to choose which one is the u. Me, I usually follow this order. It always works for me. I don't know if it will work for you as well. Okay, so L, logarithm function. Okay, for example, natural log of something, this. So if you have logarithm function in your integral, that one is going to be a u. That will be your purity. Okay. Next, inverse trig functions. Okay, inverse trig functions. This one, cos inverse, sine inverse, tan inverse, whatever. If you have it, that will be a first priority for you, isn't it? Next, algebra, right? Algebraic x, or just about x squared, whatever. So here, as you can see, of algebra, right? We have 2u or u. U is just an algebraic function, right? Okay. So yes, of algebra appears first in this order. So we're going to make this guy as our u, but come on, to make this 2u equal to u, that didn't make sense, right? Let's use a different variable now, okay? Since we've already used the u in the u substitution. Here in integration by parts, I'm going to use, what should I use? Come on, let me use m, okay, n, which one? Okay, I'm going to use m. So I'm going to write this as m dv. Yeah, better, right? So that here I'm going to have mv minus the integral v dm, right? Yeah, I don't want to use u anymore. I've already used it, okay? So it means that my m is going to be 2u, right? Okay, m equal to 2u. So let me differentiate this dm du, right? So this becomes what? 2, isn't it? So meaning that I'm going to solve my dm, right? So I need to make dm the subject of formula here. So my dm will be equal to 2 du, right? Okay, so I'm going to replace those values. And also, what is my dv? My dv is everything that remains after I take out my u, right? So what remains here is what? I've taken out my u to be 2u, and then my dv is simply sine u du, isn't it? Okay, so I'm going to get my v by integrating this. So v is simply equal to negative cosine u. Okay, please don't add plus c here. Okay, don't do that. You add a constant to your final answer. Okay, so now let's replace this. So I'm trying to integrate sine u 2u du, right? And this is equal to uv, okay? uv, so our v is negative cos. Okay, so I'm going to start with u first, 2u. This negative because it's coming from a v cos u, isn't it? Minus the integral of v, which is negative cos u times what is du? dm, sorry, this is my, I'm just confused because I'm used to u. Okay, I'm using the m instead, right? What is my dm, right? From here, my dm is what? It's 2 du, isn't it? Okay, 2 du. Okay, so I'm going to solve that, isn't it? So I have minus 2u cosine of u. This will be plus, isn't it? The integral, I can push out a 2 outside. Cosine of u du, isn't it? Okay. Now let's integrate. What is the cosine of u? Cosine of u is simply sine of u, isn't it? Okay. Yes. And what was my u? Let me go back here. Okay, what was my u? Remember very well? My u was equal to what? Root x. Get it right, okay? My u was equal to square root of x. So I can now go back and substitute everything, isn't it? So this becomes minus 2 root x cosine root x, okay, plus 2 sine root x plus c. At this point, I can add your constant integration. And this was the integral of root x sine root x dx, right? Okay, so this marks the end of our problem. Okay. So if you have any question, please ask in the comment section.